Hello and welcome back to CS103 Machines, Languages and Computation. Now that you know what an algorithm is and also what a problem is in computer science, I'd like to come back to a question which I posed at the end of week 3 to do with the MIU system. And the question was, is there a decision procedure for this system? Now that you know what algorithms are, this question is going to make a little bit more sense. So let's first of all ask ourselves, what is a decision procedure? Well, it's an algorithm, a special sort of algorithm. So let's put an algorithm here. So you know what an algorithm is now. It's a sequence of steps that computes a result for you, given an input. So the input, typically this will be a member of a set, like a member of the set of all integers, a member of the set of all strings, something like that. And the output is going to be true or false. So what we're doing is that we're feeding our algorithm a particular member of a set, and the algorithm is deciding whether or not that particular member of the set accords to some test or not. We're going to test it to see if it is one of those or not. Let's give you an example. And we'll call it the even problem. So the even problem consists of this. The input is any integer you like. So in other words, it's any member of the integer set z. Let's give it a name, this input. Let's call it x. So any integer x is our input. X is a member of z. So we'll write that x is a member of z. So there we go. That's the input. The output, what we want is true if x is even, an even number like 2, 4, 6, 8, also the negative numbers, minus 2. In other words, if it divides exactly by 2, and false if not. So that defines the even problem. We put in an integer, we want it to return true if it's even, and false if it's not. What does the algorithm look like? Well, of course, it's very simple. If x % 2 is equal to 0, then return true, else return false. And that will work and run in a finite amount of time. That's important. Runs in finite time for any input. That's an important property of the algorithm. I'll put it here. Runs in finite time for any input, not just some of them. Well, it's finite time, and it means that eventually it will give you a result. It's guaranteed to give you a result if you wait. It will eventually come up with the goods. So, the even problem, this is the algorithm. It runs in a finite time for any input, so therefore it accords to that. It returns true or false for any input. It works for any input, any member of Z it works for. So this is the decision procedure, and that means the even problem is decidable. Decidable. A problem is decidable if you can create a decision procedure for it. And for the even problem, the decision procedure is that, and it works. So it's a decidable problem. Let's now turn to the MIU system. This is the original MIU system, the one with 4 rules. The original and still the best. The MIU system. What would a decision procedure look for MIU? Well, we'd like to input here any string of characters, e.g. MIIU, for example. Any string of characters, or it could be the string of characters XYZ. Let's put some quotes around it to make sure that we know it's a string. There we go. So the input is any string of characters that you like, chosen from the set of all possible strings. Let's give it a name. Let's call it S. So S is a member of the set of all strings. Obviously that's going to be an infinite set. Any string you like, you can put it in. The output is true if S is a theorem of MIU, and false if not. So we know what we want now. Basically, we want something where we can feed into our algorithm a string. The algorithm will work around for a finite amount of time. I'll emphasize this again. Runs in finite time. It's got to return us an answer for any possible input eventually. If there is an algorithm, for doing this, then the MIU system, the MIU problem, is decidable. The question I'm posing to you, is the MIU system decidable? And the way that you'll show that is by coming up with an algorithm for me that can return true or false for any possible input. Now for MIU, that's fairly difficult, but I'll show you how easy this problem can be with another simple little system. So this little system, I'll call it the BA system. So I'm going to show you how simple it can be to create a decision procedure for a system by taking this simple example. There's only one rule in the BA system, which is that if your string ends in an A, you can add another A to it. Very simple. And the axiom in the BA system is simply BA. So what you can see is that you can start with the axiom BA. You can apply the rule, which gives you another A, BAA. You can apply that again and get BAAA. You can apply this again and get BAAAA, and so on and so forth, making lots of sheep noises. Now the question is, what is the decision procedure for this? So in other words, you've got an algorithm. In here, you've got any string as your input, and you're going to be coming out with a true for theorems false if not. So for example, if you put in the string BAAA into the algorithm, it returns true. But if you put in the string MIU, well, that's not a theorem in this, so that should output false. So the algorithm here is very simple. It goes, number one, does the string start with B? If it yes, equals continue. No is output false. So what we know is that all strings, all theorems of the BA system have to start with a B. That's pretty clear because it's stuck on the beginning of the axiom, and the only end of the string that we modify is the far end of the string. So the B is going to stay there forever. 2, does the string have only one or more A's after the B? Should have used a bit bigger piece of cardboard. If yes, then output true. Otherwise, output false. So there, this little bit here, that thing is the decision procedure for this system, the BA system. So the BA system is decidable. So this is a decidable problem because I've given you an algorithm. All you do is you test to see if the string starts with a B. If it does, you continue, otherwise you output false. And then you look to see if the string has one or more A's after the B only. So in other words, that's all you're allowed is A's. If it is, you output true, otherwise you output false. Notice it says one or more because you have to have at least one. You can't have the string B, for example. That would be a false one. So that's an easily decidable system. So BA is a decidable system. The question I'm posing to you is MIU decidable? Is there an algorithm? And the way that you would prove that it's decidable is you come up with an algorithm. So good luck, see if you can come up with that algorithm, and later on in the course I'll present what the algorithm is to you.